Alright, in this video we're going to start talking about intersections of intervals. So remember what's an intersection, so we talked about this in an earlier video. But if we have two sets A and B, A intersection with B is going to be the set of all the x such that x is an element of A and x is an element of B. Okay, so remember the intersection of two sets is just everything that's in both of the sets. Okay, so let's do just a brief refresher example, just real quick. So let's say we have 2, 3, 5, and we want to intersect that with 1, 2, 3. Okay, so if we want to do that, then what do we have? Well, just go through either one of the sets, go through each element, and then see if it's in the other set. So 2, is that in the other set? Yeah, there it is. So 2 is in our answer. 3, is that in the other set? Yeah, it is. Okay. What about 5? Is that in the other set? No, it's not. Okay, so we're done. We don't have to look at the other set because 1, if we want to look for 1, well, if it were in the other set, we would have found it already when we went through that set. Okay, but we didn't because it's not there, so the answer is just the set of the elements 2 and 3. Okay, so that's just a brief refresher of intersection. Remember, to be in the intersection, you have to be in both of the sets. Okay. So an interval is just a special type of set, right? So it's the exact same concept. So if you intersect two intervals, your answer is just going to be everything that's in both of the intervals. Okay? And it's actually pretty straightforward if we approach it like we did with unions, where we draw a number line, things like that. So if you didn't see the union video, don't worry about it. We don't really have to know that for this, but we'll just go through it all again here. So let's just start with an example. So example 1. Let's say we have A equals -1 to 5, and B equals 3 to 7. Okay, and we want to find out what is A intersection with B. Okay, so remember, the intersection of two sets is it's the set of all the elements they have in common. So it's everything they have together, everything they share, all the overlap between them. Okay, so what we're going to do is we're going to draw both of these intervals on a number line, and we're literally going to look for the overlap. Okay, so it's really not that bad. So let's go ahead and draw these on a number line. So if we make a number line here, let's see, number line. Okay, so we want to line them up and we want to put the same kind of scale on them. So -1 to 5, so -1 to 5 and 3 to 7. So let's put -1 here. Okay, we'll put -1 over here. We'll put 5 over here. Okay, and then 3 and 7. So 3 is going to have to go somewhere over here. And then 7 goes somewhere over here. Okay, so if you read everything from left to right, it's -1, then next is 3, then 5, and then 7. So make sure that we get the order correct, because that's going to help us look for the overlap. Okay, because we do want to literally look for the overlap, because that's what an intersection is. It really is just overlap. Okay, it's whatever these two sets have in common, what elements they share, what's overlapping between them. That's literally what the intersection is. So with intervals, we can literally draw them out and just look for the overlap. Okay, so now how do we do these? Well, -1 to 5 with square brackets, remember that means -1 less than or equal to x, less than or equal to 5. So we talked a lot about that in previous videos. So this means we have a closed circle on the -1 and a closed circle on the 5. Okay, so let's go ahead and draw that. So -1 to 5, so closed circle on both of those. Okay, and then here from 3 to 7, we have. So this here means 3 is strictly less than x is strictly less than 7. Okay, because these rounded parentheses here, that means strict inequality. So we have something like this going on. And remember, strict inequality means open circle. So open circle on the 3, open circle on the 7, and then everything in between. Okay. Okay. Now for the answer here, for the intersection, draw another number line. And then what we do is we literally look for the overlap. Okay, so where is there overlap here? This goes, so let's zoom in a little bit. Okay, this goes from -1 to 5, including 5. This goes from 3 to 7, not including either. Okay, so what's the overlap though? What do they have in common? Well, notice the overlap, so if we just look right at it, we see the overlap is just this piece here. Okay, only this piece here. Okay, so that's what they have in common. Okay, so yeah, this first number line has stuff over here, but that's not part of the second number line. This second number line has stuff right here, but it's not part of the first number line. So the only place where they have stuff in common is right in between here. Okay, so what is that? Let's drop it down. So if we drop it down to here, what's that? That's 3. If that drops down, that's going to be 5. Okay, let's zoom out a bit here. Okay, so this drops down to 3, this drops down to 5. Now, what open circles, closed circles, what? So we have to be very careful here because 3 is part of this interval up here. Okay, 3 is like a closed circle up here because 3 is part of that interval from -1 to 5. Right, 3 is part of that, but 3 is not part of this. Okay, this is everything strictly greater than 3 and strictly less than 7. So in the second interval, x is not 3, so it's not part of the intersection because it's not in both of them. Remember, to be in the intersection, you have to be in both A and B. Okay, but 3 is not in B. Okay, 3 is only in A. So that's why we have the open circle, because it's not part of the answer. It's not part of this intersection here because 3 is not in B. Okay, remember you have to be in both to be in the intersection. Okay, what about 5? Well, 5 is part of A, okay, because square bracket, and 5 is part of B because 5 is between 3 and 7. Okay, so 5, x less than or equal to 5, so 5 is part of that. 5 is between 3 and 7, so 5 is also part of that. So we have a closed circle on the 5, and we see that just from the overlap, we get everything in between. Okay, everything in between. Okay, so what's our answer then? So how do we, if we express that in interval or inequality notation, that's 3 less than x less than or equal to 5. Okay, but if we want to express that with interval notation, which is really how we should answer the question, what's that going to be? So let's zoom out a bit again. So that's going to be 3 comma 5. So remember, smaller one first, comma, larger one, and then less than or, so let's do strict inequality here. 3 is strictly less than x, so rounded parenthesis here. X is less than or equal to 5, so square bracket over here. And that's our answer here. Okay, so again, how do we get that? Just draw each of these on their own separate number line. Make sure you line them up so that the numbers kind of work together. -1, then 3, 5, 7, right? Line them up like that. And then just literally look for the overlap because that's what an intersection is. It's what they have in common. It's what's overlapping there. So with a number line, we can literally look for the overlap if we draw them neatly enough. Okay, then drop down the endpoints. So 3 and 5 are the endpoints here for this overlap here. And then be careful of open circles and closed circles. So again, 3 has an open circle because 3 is not part of this interval here. X is strictly greater than 3, not equal to 3. Okay? But 5 does have a closed circle because 5 is part of both of these intervals. X could be equal to 5 up here, and 5 is between 3 and 7. So 5 is part of both, so it gets the closed circle. And everything in between just happens automatically because that's literally what the overlap is. Okay? So this number line picture here corresponds to this inequality notation, which corresponds to this interval notation, which is our answer. Okay, okay, so that's it for example 1. Now I want to point something out which is very, very, very important. So when you, this is worth writing down also, when you intersect when you intersect two intervals, or really any number of intervals, but you can always think of it as 2 at a time. When you intersect two intervals, there are only 3 possible types of answers. Okay, when you intersect two intervals, there are only 3 possible types of answers. Okay, so what are they? Let's come over here and write that. So when you intersect two intervals, there are only 3 possible types of answers. So I'm out of room over here, so I'm going to awkwardly come over here and write it. The types are 1, an interval. That's actually what happened here. Okay. So here we intersected 2 intervals and then our answer was another interval, so that could happen. The other possibility is a single point. A single point, or a single number, right? A single point or a single number. So that could happen. We'll see an example of that later. Or part 3. The empty set. Okay, so when you intersect two intervals, you only have 3 possibilities. Okay, your first possibility is an interval like we just had here with example 1. Second possibility is a single point. So it could be possible that or it could be the case that these two intervals overlap in only one single point. And we'll see an example of that later. Or 3, it could be the empty set, which means there's no overlap at all. Okay. So again, just be very careful. So what this means is your answer will never be something like 2, 3, 4, 5, right? So if you intersect two intervals, you'll never, ever, ever get an answer like this, okay? Because that's not how intervals work. Remember, intervals include all of the real numbers in between, not just the nice pretty ones like 2, 3, 4, 5, not just those nice ones. So remember, -1 less than or equal to x less than or equal to 5, that's all of the numbers in between, not just -1, 0, 1, 2, 3, 4, 5. That's all of the numbers in between, including all the fractions, decimals, all the ugly numbers, things like that. That includes everything. So that's why when you intersect two intervals, there are only 3 possible types of answers, and it's an interval, a single point, which you must also express as a set, but we'll talk about that in the next example in the next video, and then 3, the empty set. Okay? So that's it for example 1, and this very important point here, which we'll bring up again in the next video. So example 2 coming up in the next video. And again, the answer here was 3 to 5, like this, open parentheses here, square bracket here, rounded parentheses here, and square bracket here. Okay?